In this example, it looks like we have a nice matrix equation. We have a few column matrices here. Each of these column matrices is going to be 3 by 1 in dimensions, so 3 rows in just that single column. And it looks like we're on the left side here, we're subtracting. So when we subtract, we make sure that they're the same dimensions, which we did already. And then we just go ahead and subtract the corresponding entries. So the first entries, second entries, and third entries. And we're going to say, after we subtract this, that that's going to be equivalent to this matrix on the right side. So let's go ahead and do that. So we'll have ourselves a 3 by 1 here. So 2 minus m will be the difference here. And then negative 4 minus 7, that'll be a negative 11. And then 2p minus 5, we can put right there, 2p minus 5. And we're saying that that's equal to negative 5, n, and negative 1 in that column matrix. So now it seems like we have equivalent matrices. We have this column matrix, which is equal to this column matrix, which that's really nice because with equivalent matrices, we know that all the corresponding entries are equal to one another. So I know that 2 minus m equals negative 5. So let's go ahead and write that down. 2 minus m equals negative 5. I also know that negative 11 equals n. Okay, well, I'll just say n equals negative 11, and there's that value, so we're done with that one. And finally, 2p minus 5 equals negative 1. Okay, so it looks like we have ourselves two equations that we need to solve. This one for m, and then this one for p. Okay, so let's start up here. This m is a negative m, so let's go ahead and subtract 2 from both sides. We see that negative m equals negative 7. And you know, whenever we divide both sides by this negative, we can just cancel them out there, and we say m equals 7. Okay, so there's that value. And finally, on this last one, let's go ahead and start by adding 5 to both sides so we can get rid of that 5. So we have 2p equals 4, and we go ahead and divide both sides by the 2. It looks like p equals 2. So here are the three values then. M is positive 7, n is negative 11, and p is positive 2. And that makes this matrix equation true. And let's just go ahead and plug them in to verify. So we had our value of m was 7, so 2 minus 7 is negative 5. Yeah, that's true. And then negative 4 minus 7 is negative 11, so we said n was negative 11, and that's true as well. And finally, we said p was 2. So 2 times p is 2 times 2 is 4, and 4 minus 5 is negative 1. So that works out just fine.